Good evening, everybody. My name's Mark Johnson, and I'll be your MC for the evening. On behalf of myself and the other directors, Adam and Luke, I'd like to, and everybody else at Shine, I'd like to thank you all for coming along. A quick few housekeeping rules. We do have exits out the back and that side, over the wings. And also around to the left and right down the back are the toilets. If during the presentation you could hold the questions, I'm sure you'll be full of, fantastic, riveting questions. But if you could hold the questions, we will be having a Q&A session at the end. So if you could hold those to the end, that would be great. Before we jump into the presentations, I'd just like to talk briefly about the journey that brought us here. In 2011, we created the TEL group within Shine with the goal of encouraging innovation and thought leadership within Shine. We hoped that we could harness some of the great work going on in Shine and in partnership with our clients, and to showcase it to others in Melbourne and via the internet to the world. Sorry, excuse me. Thanks to that work, we were invited to the Amazon Web Services Advanced Consulting Partner Group in 2012, and last year we were invited to be part of the Google Cloud Platform BigQuery Partnership Group as well, only the second Australian company to do so. This evening we'll be providing some insights into both of these platforms, and this leads me to introduce my first presenter. Graham Collie is a senior consultant and a member of the TEL group. His current assignment is at Telstra, and based on some of the work there, he was invited, along with Luke Alexander, a director, to be interviewed for the Google Developer YouTube channel last year. Please welcome Graham.
Get rid of that beer. Get out of here. All right, thanks for that great introduction, Mark. I just want to start off with one thing. I am Irish, so I've got a bit of an accent. If I say the number 3 or 3, please don't laugh, because there's lots of trees in this presentation, all right? So I'm going to, don't heckle. All right, so it's an exciting time to be a developer, I would say. It's a really exciting time. So let's have a look first at what we're going to look at today. So here's our agenda. I'm going to give you a little brief background to the problem that we solved up at Telstra, using the cloud and using, in particular, the Google Cloud Platform. I'm going to have a look at 2 products today, data flow, BigQuery, and then at the end, we're going to have a look at a demo of BigQuery, just to give you a flavor of how it looks and how it actually works. So, big data is exploding, right? You're hearing it everywhere. You look in your LinkedIn feed, your Twitter feed, and all you can see is big data. It's everywhere. And it's really, really hard to collect, sort, and organize this data, right? It's just really hard. And a lot of organizations, they're just wrangling with this data. It's given the current tools that they have to work with it. And what it boils down to is really this, right? You've got all this data, but what you really want to get out of it are insights. That's what you really want. You don't want to be messing around, spinning up clusters, and worrying about infrastructure and all that kind of stuff. You just want your insights. This is a great quote. I actually found this. It was on my Twitter feed. I don't know who actually said it, but I thought this was a really good quote to start off with. So let's have a look at some big data challenges, okay? Pretty high level. We'll have a look at them. Data transportation. What's that? Well, that's getting your data into the place where you need to start working with it, whether that's getting into the format that you need it, applying business rules, cleaning it, all that kind of stuff. Deployment and performance, spinning up big clusters, Hadoop clusters, and then tuning those clusters to work with that. It's just a lot of hard work. Data cleansing, applying business rules, we already mentioned that. And finally, the critical one, right? Time to insights. You don't want to start querying your data and then head off for coffee and come back, an hour later. That's a pretty long coffee, actually. A few hours later, and have to wait for this analysis to run. You want it quick, and it's the way data is being ingested these days has changed, right? It's becoming real time. We want to be able to analyze this data in real time. So we identified a very, very high level big data workflow, okay? So let's have a look at that, and let's break it down a little bit. Can everyone hear me okay? Is the mic okay? Yeah? Okay, cool. So the first step, we've got ETL. So extract, transform, load, all right? So extract your data from multiple sources, bring it in, transform it, group it, aggregate it, whatever you want to do, clean and apply business rules. And then you're going to load that data into some kind of analytics engine where you do your analysis for insights. So that's the second step. Load it into your analytics engine, start analyzing. And hopefully you get insights out of that, right? So that's our big data workflow, simplified. So Mark mentioned I'm up at Telstra at the moment. And we solved a problem up there. That's what we're here to share with you today. Bit of a story, bit of a background. So Telstra, of course, one of the largest digital publisher here in Australia. And they got massive websites like AFL, it's the one on the right, NRL, I'm a rugby man, so I have to put that one up. And they've got lots of digital real estate space. What do they do with that? Well, it's not rocket science. You put lots and lots of ads, right? Generate some revenue. With all these ads, they were generating a massive amount of data for Telstra. Huge amount of data, for talking billions of rows per month, terabytes of data, and they wanted to analyze this data. And we were really struggling to analyze. It was just so big. And the story kind of went like, go to data warehouse, and we'd say, can you give us a server? Yeah, sure, we can give you a server. Give us 6 months and lots of money. Okay, cool, give us and we'd work on it. And then we'd outgrow that, and we'd need another server, another 2 servers. We'd go back to data warehousing. Can you give us, yeah, give us another 6 months. And it just wasn't working for us. And what it really boiled down to was this. I don't care about the infrastructure, right? I just care about the results. I don't want to worry about that stuff. We want to get our insights out of our data. So we took a step back. We kind of went, okay, well, could we harness the cloud? Could we use cloud services and cloud products to help solve this problem? And then we looked at the big data landscape and we went, whoa, it's pretty overwhelming. There's a lot going on there. Lots of things. But if we just go in here, we've got Google, right? They're pretty innovative. They seem to know what they're talking about when it comes to big data. Do they have any products that could help us out? And turns out they do. They've got 2 products, right? Dataflow and BigQuery. So that's what we're going to talk about today. Or at least I'm going to talk about that, and Shane will come up and talk a little bit later about AWS. So let's revisit our big data workflow. Okay? Where do each of these products fit in? Here. Dataflow is going to be your ETL, so extracting, transforming, loading all your data, doing all your munging. And BigQuery is your analytics engine. And that's how each product fits in. So let's have a look at Dataflow first. All right. So what is it? So we already talked about ETL, right? So it's massively scalable. It can just spin up clusters, spin up servers for you on the fly. It's got 2 modes, batch and streaming. It's the successor to MapReduce and Hadoop. So Google were actually the ones who wrote the white paper for MapReduce. And they wrote it some time ago. And they announced recently that they actually don't use MapReduce anymore. They stopped using it 7 or 8 years ago. And the reason being it's geared towards batch processing. And it was just too slow for them. So they've developed a new technology. And that's what Dataflow is based on. It's called Java Flu. It's a fully managed service. Okay? What does that mean? Well, you write what's known as pipelines in this domain. Write your data pipeline, define your inputs, transformations, outputs. That's a pipeline. And it will manage the full life cycle of that pipeline for you. We'll have a little look at that later on. So by managing, what do we mean? Well, this is what it looks like, simplified version. Got Dataflow orchestrating the whole pipeline for you. It will pull files, whether it's CSV or JSON, whatever data you've got. It will pull it from Google Cloud Storage. It will spin up compute engine instances for you, create a cluster, and then it's going to write that data to BigQuery where you can finally do your analysis. And that's where the fun starts, right? So we talked a little bit about pipeline. That we know what a pipeline is now. That's our data pipeline, input, transform, and load it. So there's 3, there we go. There's 3 pipeline runners, okay? So your first runner is your local runner. And that's for your devs doing local development, debugging and testing, and developing your software. And you don't get charged for that. Important. Your second runner is Google Cloud, right? Write your pipeline and then submit it to the service, and it will run on Google infrastructure for you. And the final one, which is actually a pretty new one, is you can actually run your pipelines now on Apache Spark clusters. For those of you who might not be familiar with what Apache Spark is, Apache Spark is claimed to be 100 times faster than Hadoop, so they're saying, and it's all in memory. So it's pretty cool, and it's a very fast growing project. It's an Apache project. So that's one to keep an eye on. But today, we're going to have a look at running all this stuff on Google Cloud. That's what we're here for, okay? So data flow loves the jobs you hate, all right? Well, what does that mean? So it's going to spin up the cluster for you. Don't have to worry about it. It just does it for you. It's going to actually optimize and deploy your code. So you're going to upload your code to the service, and it will actually optimize it for you before executing it. It's going to dynamically scale up and down. What does that mean? Well, you can say, I don't know, start with 4 servers as my floor value, 64 servers as my ceiling value, and data flow, you know what, you take care of how many servers you think should be running while you're processing my data. And as your load increases and decreases, servers come up, servers come down, and that's dynamically scaling. And finally, it's going to tear the whole cluster down for you. So again, you don't have to worry about it. Just tears it down. You're done. So, what does that kind of look like? Well, it's not cloud data. It's hard to say what cloud data flow is in a screenshot. This is what happens when you execute one of your pipelines and you go to the Google Developers Console and you actually see your pipeline running. And you can see down here, it's a dynamic cluster spun up. That list that you saw are all your VMs which are spun up for you to run your pipeline. Get CPU and memory and I/O and all that kind of stuff. Boring stuff. Who cares about that? Insights. So what does all that mean? So we've talked about spinning up clusters and tearing them down and dynamically scaling. Well, this, right? You just don't have to worry about it. You just focus on your code. That's where your insights lie, in your code. So speaking of code, what SDKs do you have available? So I'll mention at this point in time, Dataflow is actually a beta product. Google are looking to come out of beta in the next 3 to 4 months to a GA release, general availability, I think that's what they call it. But it's beta at the moment. So it's a little bit immature. You've got 2 SDKs currently available to develop on top of this. You've got Java, assume everyone here knows what Java is, and you got Python. And Python itself is actually only a beta SDK. So 2 libraries, or 2 SDKs. So once you pick your library, you're going to start writing some code, right? So what do you got to do? 5-step process. 1, you need to configure your pipeline resources. What does that mean? That means you're going to say how many servers you want to start your cluster with, how many you want to scale up to, whether you want scaling on. You can actually turn scaling off. You can say, I want you to run with a fixed amount of servers. Don't scale. You've got that option. You can also specify, for example, which data center you want to run in, which region, which zone, all those types of things. So you've got to first configure your pipeline resources. Second step, define your inputs. And the emphasis here on the S on inputs, plural. You can have multiple inputs coming into your pipeline. So I don't know, you got some CSV over here in Google Cloud Storage. You've got some data sitting in BigQuery in a table. Pull it in, do all your munging, and load it somewhere else. And by munging, we mean our transformations, right? And again, you can have multiple transformations. It's not just one input, one transformation, one output, multiple. Then you're going to define your output. So after your transformations have finished, where do you want your results to go? Do you want to go back to Google Cloud Storage? Do you want to go back to BigQuery? That kind of stuff. And again, you can have multiple outputs. And finally, just pull the trigger and see what happens. Don't test it first. It's a good idea. So when you do pull the trigger, this is kind of what it looks like. So again, this is the Google Developers Console, okay? And I've taken a screenshot of one of our pipelines running. It's not rocket science, really. You got some inputs, right? You got some transformations happening, munging that data, cleaning it, applying business rules. You got some outputs. So in this case, we were reading from Google Cloud Storage, we were doing 3 transformations, and then we were outputting it back to Google Cloud Storage for further analysis. So when we were running that pipeline, we actually spotted this. I thought I'd take a screenshot of it. It's pretty cool. We were writing 1.4 million records a second back to Google Cloud Storage. That's incredibly fast. 1.4 million. That pipeline that I just showed you there, we were, I think from memory, we were processing about 5 billion rows. 5 billion rows, and we were able to write 1.4 million a second back out. That's, yeah, it's incredible. So, that's all cool and speed and wow, but what's this stuff cost, right? That's the important question as well. It's really important. This is where it gets a little bit tricky to talk about cost, but yeah, bear with me. So your first cost is going to be a service cost. You've got to pay an additional charge of 1 cent per VM in your cluster. That's just like a little surcharge they're going to charge you. The second then is all your cloud resources that you're using to run this pipeline, right? So whether that be all your VMs in your cluster, you've got to pay the normal rate for running those VMs. Storing data in Google Cloud Storage, it's not free. Google's a business, they're there to make money. And whether you're writing to BigQuery, you're going to have to pay for that data in BigQuery as well. So you're looking at that, right, and you're going, oh, great. I've got a question mark, and I've got 1 cent per VM. That's all that means. I can give you an example. Up at Telstra, we pay about $700 a month, and we push through about 50 terabytes of data. $700, that's all it is. Security, that's pretty important, right? You're entrusting your data with someone else. So let's have a look at security. All your communications encrypted and over HTTPS. Bit of a given, I would say. All your work by worker here, we mean our worker nodes in our cluster. All that communication is over a private network which will be spun up for you, created for you when your pipeline runs. Your data is encrypted at rest, and it's not persisted. So remember, the pipeline will be torn, or the cluster will be torn down when your pipeline finishes. VMs go away, data's gone away. And you can specify your region and your zone as well. We touched on it a little earlier. So that's data flow. So let's jump into BigQuery. So going back again to our big data workflow process, that's where data flow fitted in. And this is where BigQuery fits in. So we've done all our munging, we've gone extract, transform, load, and we've done some aggregation and cleaning, and then we want to really analyze this data and gather our insights. So what is it? So it's an analytical DB as a service, or an OLAP, online analytical processing tool. Understand SQL, right? I'm hoping a lot of people here know what SQL is. So I got a bit of a dodgy look there. You really don't know what SQL is? So write some SQL, point it to a table, click run, you're done. Incredibly fast. Scales effortlessly as well. All right. So this is one thing about BigQuery that's quite interesting. You don't get to configure any clusters. You don't get to say, I want 4 servers running, or 64 servers running, or 100 servers running. It's a black box. Point it to your table, write some SQL, press run. You have no idea how many servers are running that query. It's all distributed computing. What actually happens is your query is taken out, it's given to a master node, which breaks it down, gives it to some worker nodes, and says, okay, you do this piece of work, you do this piece of work, you do this piece of work. It's all shuffled back together, and you get your results. But you have no idea how many servers are actually running. Really important. BigQuery is append only. It's not like a traditional RDBMS. Can't update or delete records. It's an analytical tool, so it's append only. You're not going to use this for transactional processing. So what makes it so fast? Right, well, on your left, you got a traditional RDBMS, right? Row orientated. On the right, BigQuery, column orientated. So when your query actually starts running, it can skip all that data that it doesn't need to look at and go straight to what it does need to look at. It makes it really fast. And you get much better compression, of course, as well, with column-based. And finally, it's running on Google infrastructure. They've got the the horsepower to run this stuff. BigQuery setup. This was an interesting one to try and get a slide around. There's really not that much that you need to do. You got a Google account. I'm guessing 70% of people here, 80% have a Google account. You got a credit card. That's not my credit card, by the way. It's a platinum credit card. Hint, hint, nudge, nudge. Got a Google account, got a credit card. You got some data. That's it. You're pretty much good to go. You just log into BigQuery, plug in your credit card details, pull in some data, and start querying it. That's it. No setup, no clusters, nothing. So talking about getting data into BigQuery, how do you do that? There's 3 ways. There's 3 ways. Okay. We talked about data flow, writing to BigQuery. You can bulk load CSV and JSON, just bulk load it in. But you can also stream data in real time. It's got a streaming API. There's a couple of caveats with both of those. First one, there's a 5 terabyte limit when you're loading data into BigQuery. And that caught us out a few times, so watch out for that one if you do decide to use this product. You might have to split your load jobs up into multiple ones. Or you could actually go to your Google rep and ask them to lift your quota. They say that on their website. They did it for us. They lifted it a tiny bit. I think one of our jobs was running with 10 terabytes, and they lifted it for us just to get us over the line. But just be wary of that. And the other one is with streaming. I haven't highlighted it here, but you can only stream 100,000 rows per second per table. But that's a lot of data. So if you've got more than that, again, contact your Google rep and try and lift it for you. But I'd be pretty surprised if people are streaming more than 100,000 a second. So we talked about SQL. All right, this is a screenshot of BigQuery. You can see how simple it is. This is just the browser tool, right? So on our left there, we've got some tables that we've loaded in, some publicly available tables. And over there in the top right, that's where we're going to write our SQL. And then the bottom is our results. That's pretty much all there is to it. Now, I'll mention at this point in time, we found when you're working with BigQuery, it tends to struggle with joins and really big joins. It just really starts to slow down. Whether that's a problem with column-based architecture, not quite sure. We need to look into that a little bit further, but it really does struggle with joins. So before trying to do all your joins in BigQuery, take a step back, do all that stuff in pipeline, in data flow. Okay? Do all your transformations and your denormalization at that point in time. Then bring it into BigQuery for your analysis. Don't try and do too much joins in there. And there's a few little nuances with the SQL. It's not pure POSIX SQL. So that's BigQuery. But you've also got some SDKs, just like data flow, right? So it's got a RESTful API. And you can see straight away, boom, this is a lot more mature. This product's been out since 2010, 2011. You got Java, iOS, Python, they're all there. So go nuts and build your products. All right, money. How much is this stuff going to cost? Again, there's 3 things that you're going to have to pay for. The first one is querying. You got to pay $5 per terabyte queried. I'll mention at this point in time, this is US currency, not Australian currency. I was a little bit lazy to change my slides 5 minutes before the presentation when I noticed it. So, US currency. $5 per terabyte in your queries. Streaming, if you're going to stream your data in, like we talked about with the streaming API, 1 cent per 100,000 rows. And then your final cost is storage. You've got to pay for that data that's sitting in there. And it's 2 cents per gigabyte per month. Again, a bunch of numbers on the board. Well, what does all that mean? We can give you another example. $1,500, and we analyze about, on average, which is growing considerably, about 100 terabytes of data up at Telstra. Costs $1,500 for all in. It's not particularly expensive. But maybe it's not expensive because we found some cost-saving tips. So let's share them with you. You can use caching, right? So when you write your query, BigQuery will actually cache that for 24 hours as best it can. That's what it says on the website, as best it can. So if you don't change your query and you don't change your data set, it will cache it for you. It's got a feature known as table decorators. So instead of querying the whole table, you can say, I just want to query the last day's worth of data, or I just want to query the last 2 days worth of data, 3, and so on. But there's a caveat with that. You can only go as far back as 7 days, so watch out for that one. But it does keep your costs down. And it's good as well for when we were doing our streaming project, we found this really useful. When our data was pouring in, we would just use table decorators to analyze it, instead of going over the whole data set. Excuse me. Start small and refine your query. I would have thought that's a given. It's a pretty good pattern to use, right? In all software development. You don't just jump in at the deep end, go nuts. Oh, let's load a few terabytes in and start querying it, and then let's load some more, and this is cool, and start querying some more, and then get a bill at the end and go, whoa, it's pretty expensive. So get some data in, get a subset of it, write your query, refine it, get it into the state that you're happy with, and then go big. Housekeeping. So it's really easy to forget yourself when you're working with cloud products. Load some data in, put it in the background, load some more data in, put it in the background. You're paying for that data. They're going to charge you. It's a business. You're going to charge you for that data. So any data you don't need, get rid of it, delete it. And finally, this is actually a little hidden gem of BigQuery. Not a lot of people know about this. We found it pretty late in our project. It's called dry run. So when you're building your product and you're using the RESTful API, you can actually specify dry run to be true. And it will actually validate your SQL for you before running it. That's pretty cool as well. So try and keep those in mind if you're going to be using BigQuery. Security. Again, pretty important, right? So data is encrypted at rest. Should be a given. Row column level security is now possible. So this is a relatively new feature of BigQuery. They only released this a few weeks ago. We didn't have it at the time of our project, but yeah, it's a new feature. You can't specify your region and zone, but, and this is a really, really big but. What's wrong with this picture? You don't have a data center here in Australia. So if you're in finance, for example, banking, and for legislative reasons, this mightn't work for you. So based on your use case, you really need to look at this. Don't have a data center down in that country down there in the bottom right. You do have one in Ireland, though. I just spotted that. I think it's in Dublin. Not sure. So yeah, keep that in mind, guys. All right, let's have a look at this stuff. So what does it look like? Well, we can't show you Telstra data, of course. Who wants to see Telstra data? Ad serving logs anyway, it's pretty boring. Sorry to all the... Is there any Telstra people here? Oh, good, okay. Ad serving logs, pretty boring stuff. So, just to give you a flavor what BigQuery can do and what it looks like. There's this database called GDELT. And it's publicly available on the internet, and it stands for Global Data of Events, Location, and Tone. And it's just all of the world events compiled from world news media, and it's just put into this database, publicly available, protests, conflicts, elections, politics, and all that kind of stuff. And it's all there for you to have a look at and play with. The table we're going to be looking at is 318 million rows, 112 gigs worth of data. Not as big as the data sets that we've been working on up at Telstra. Still meaty enough to give you a good flavor, good feeling for what this thing can do. And like I said, publicly available, so you can head off and download that. And it's actually already available in BigQuery. I think I already said that, but it's already available in there and it updates nightly. So for the demo, we thought, well, let's analyze all the world protests since 1979, the year I was born. So I'm a 70s kid, so I picked that year, 1979. Just the 70s kid. All right, what do you got to do? Head over to BigQuery, right? And the first thing you got to do, select the table that you want to analyze. And here we go. GDELT's full, there's our table size, 112 gig, 318 million rows. Go up, write some SQL, do some sums, counts, aggregations, group bys, all that kind of stuff. Click run, let your query run, 3.7 seconds. 13 gig processed. Results a lot long, the number of events and all that kind of stuff, and there's a result set coming back, 250,000. That's pretty quick. Now, for those of you who've got a keen eye in the audience, you might have spotted the table was 112 gig, but the query actually only processed 13 gig. Cast your mind back, BigQuery is column-based. So you only pay for the columns that you access in your query. If I was to do a foolish select star from that table, I'll get charged for all the columns. But because I was only accessing a few, I'm going to get charged for those few. It's awesome. So you got your results back, and there's your insights. Yeah, it's cool, but we thought just to finish it up, a little bit of eye candy. It's a little bit boring just looking at tables and numbers. So what can we do with that? So we pulled down a third-party BI tool. So that's probably what a lot of you people are going to do, right? You're going to analyze your data, you're going to crunch through it, and then you're going to plug it into a BI tool like Tableau or Yellowfin or whatever that is. So you can just visualize this stuff. And this is what it looks like. This is the results of running BigQuery into a third-party visualization tool. And we had a look at this, and we first looked and we went, oh, that's just cool, because there's lots of flashing or red dots. But it's really interesting. Right about now, you can see the dawn of the digital age, right? The internet, mid-90s. And the communication just explodes, just goes nuts. 2000s, India's on fire. Lots of protests in Argentina, right? Look at it now, 2014. So, yeah, just thought you'd give you a flavor of what you can actually do with this stuff. So, what does our conclusion look like? We've looked at two products, right? Use Dataflow for your ETL, extract, transform, and load, clean all your data, denormalize it, all that kind of stuff. But beta, it's beta. And we've found it's definitely a beta product. We found a few problems along the way. The Google guys, they're pretty good. That you raise an issue on Stack Overflow, say, hey, we found a problem, and they're pretty responsive. Yep, acknowledge it, and they're all out of fix. So it's not too bad. BigQuery is a lot more mature. It's a no-lap tool. We've talked about what that is. So use BigQuery for your pure analytics. So that's digging in, interrogating your data. I would like to say it's pretty simple, fast, scalable, and cheap. I think they hold true. And actually, the simple part, for me at least, this is where Google are trying to pitch all this stuff. They're just trying to make it simple. They want to lower the barriers of entry into this kind of stuff. Just make it as simple as possible for developers to get up and running on this. And you can see with Dataflow, you don't have to worry about infrastructure. You don't have to worry about clusters. They'll handle all that, outsource all that stuff to them. And it's scalable. BigQuery you saw just off. Remember, no data center in Australia. It's a really, really important one. And finally, if you go onto Google and go Google, and free credits and Google Cloud, it's $300, you can just start playing with this stuff and have a feel for it. So I would say that's about it from me. So thank you very much.
Thank you.
Have a beer now?
Yes, you can have a beer now. Yes, help yourself. We're going to have just a quick 5-minute break if you'd like to go to the toilets or grab a quick drink and then come straight back in again. Then we'll start the second half of the presentation on Amazon. All right, thanks everybody. That was fantastic. Now, if the entire first half was on the Google Cloud platform, now we're moving on to the Amazon Web Services platform. It's my great pleasure to welcome Shane up to stage, who is a senior consultant at Shine and part of the DevOps group with us.
Hello. Hello, everybody. So my name's Shane, and I'm a consultant in the DevOps team at Shine. And so I worked on the project with Graham and the team for a little while. But I work primarily with AWS and the services that they offer. And so towards the end of the implementation there, one evening Graham and I were having beers and we were chatting about, we were pretty happy with how it turned out. We were able to provide these really cool insights really quickly and the value we were able to give to our customer. And one of the things we're talking about is if we were to implement this using a different stack, using Amazon, how would we do it? Would we be able to get the same sort of insights in the same sort of time frames? And so how would we solve that problem? So we started doing some reading. we sat down. We decided we're going to try it. We're going to try and implement this. And so we started doing some reading, and we realized at the outset that we might not get a one-for-one mapping of products. You know, with BigQuery, they might not have an equivalent, but there's generally something that's going to be offering around the same kind of thing. We wanted to get to the end result, which is the insights. So we decided on 2 products to try. The first one is called Data Pipeline. This is going to be our ETL tool. And the second one was Redshift. This is going to be our analytics engine. It's going to perform the big queries for us. So we went back to our workflow and decided how we're going to fit these in. So first of all, Data Pipeline is our ETL tool here. This is the product that's going to extract, it's going to pull the data from our input source, it's going to do our transformations, pull out any rows that we need to do the insights, and then ultimately it's going to load that into our analytics engine. And so for our analytics, we've got Redshift. So first up, we're going to have a chat about Data Pipeline. This is what the icon looks like. Okay, some highlights. So as I mentioned, it's an ETL tool. Yeah, you define an input. It's going to pull that data from your input source. You define some activities or some transformations that you want to happen to that data. You might want to pull out some specific rows, or in our case, we found that we needed to change the column names to lowercase. But that's okay. And ultimately load that into our analytics engine. It's schedule-based. This is not a streaming tool, so it's not going to analyze your data as it's being written. It's not going to happen at the same time. You would define a schedule that might be once a day, once an hour, once every 15 minutes, and it's going to spin up the resources and take action on that time frame. Just like Dataflow, it manages your resources for you. So if you want to run your operations on a Linux box, it'll spin up that box for you. It'll load the software, it'll mount the data sources, do all the activities, and then it'll ultimately tear it down again. So you're only paying for the resources while it's up. And it's highly customizable. One of the things that really impressed me about this tool is how well you could integrate this with your existing infrastructure, your existing applications if you want to, but I'll talk about that more in a little while. So this is kind of the overview of how it looks in the context of our solution. So up the top here, we've got Data Pipeline. This is going to be sort of orchestrating all of our operations. So first up, we've got S3. S3 is Amazon's highly scalable storage solution. So we generated a bunch of logs. We emulated what we were doing at Telstra, and we put the logs in S3. This kind of represents Google Cloud Storage, kind of a one-to-one mapping there. Next up, we've got EC2. EC2 is basically it's a service you can spin up servers. You can have a Linux box, you can have a Windows box. In our case, we determined that we wanted to run our transform activities on an EC2 instance, on a Linux instance. But it doesn't have to be EC2. You could have a MapReduce cluster here if you wanted to. If you wanted to integrate this with your in-house written application, you can. You can basically anything that has access to the internet and access to Amazon's API, you can integrate with your pipeline here. And then ultimately, we're going to send it off to Redshift. Okay, so how do we set up pipeline? So there are a couple of ways, but the way we went with was using the web console. So you can see here on the left, we've got pretty much a one-to-one mapping of what our diagram looked like before. We can literally drag around the icons on the left. On the first one, we've got our S3, we've got our import operation, and we've got Redshift. On the right-hand side, we can specify parameters like, what's our S3 bucket name, what's our Redshift credentials, what's our table name, some various options, that sort of thing. We can also specify, if we're using an EC2 instance, how big is that going to be? What type is it? If we want a MapReduce cluster, we can specify parameters for that as well. Okay, so security. this is a pretty big topic of conversation for any organization when they're entertaining the idea of moving their services into the cloud. You're essentially entrusting your sensitive data with a third-party service provider. So what measures are being taken to secure my data? Well, first of all, in Amazon land, you can specify a private network. You have the option of using, basically it's a virtual private network. VPC stands for Virtual Private Cloud. You have full control over your IP addressing. You can set up subnets, that sort of thing. You can use security groups and ACLs. You have really granular control over which servers can talk to which other servers, that sort of thing. And also encrypted traffic as well. You have the option of storing your data encrypted in S3. Everything's transferred over HTTPS, all that sort of stuff. Okay, so what does it cost? Well, our pipeline costs almost aren't worth mentioning. It's $1 a month to have it defined and sitting there. The real costs, not in the pipeline definition, it's in the resources that are used for running the operation. So in our case, we wanted to use an EC2 instance. You pay for the time that EC2 instance is up. If it's a big instance, you pay a bit more. If it's a small one, you pay a bit less. This really depends on what you want to do. If you've got a MapReduce cluster, it's going to cost a little bit more again. Okay. On to the exciting stuff. So, Redshift. So Redshift is a purpose-built analytics engine. I'm going to head over to our workflow again, and it fits right in there under Analyze. Okay, so some highlights here. It's a purpose-built engine for analytics. You wouldn't use this for your transactional stuff. Most organizations that use a data warehousing solution like Redshift, they'll have a separate database for their transactional stuff that might sit behind their web application or whatever, and then they'll send the data over to Redshift for the analytics. It's distributed, it's scalable, it's really scalable. So in the background, you'll have, it's built to run on several servers, and you'll have your workload distributed, but you don't have to really worry about that. It still acts like a regular database. There's one endpoint to connect to, but in the background, the work's distributed, and it's really quick. It's extremely scalable, so you can start off with one node. It can be a small little node if you want. And then as your storage requirements grow, you can just add another one. If you need faster instances, you can just upgrade them to faster boxes. Just like BigQuery, it's column-based. This makes it really quick. And you only have to read and analyze the data that you're interested in. It's not append only, so you can update the rows if you want to. Again, it acts like a regular old database. One of the biggest difference here is you're not paying per gigabyte or per terabyte like you are with BigQuery. You're paying for the cost while that box is up. If you've got an instance running with no data in it and you're not using it, you're still paying for that instance to be up. And the more instances you've got, the more cost it's going to be. So how do we set up Redshift? I already mentioned it acts just like a regular database. You've got this nice wizard here. You can just specify your database name, your username and password. You can change the port if you want to, just like a regular database. On the next screen here, you specify how big you want them to be and how many of them you want. It's very easy. Moving on, you specify some security rules. If you want the database to be encrypted, you can do that. If you want it to be publicly accessible, you can do that. It'll get a public IP address. It's no problem. This kind of really drives home the point that it's kind of your infrastructure. It's hosted by Amazon, but you have to really specify how you want it. You have to plan out and architect that solution. It's not dynamic in a black box like BigQuery is. Okay, so how do we use it? I've mentioned this a few times already, but it acts just like a regular database. In fact, it's based off PostgreSQL, which is it's a really mature database. It's open source. Most developers will use it on their laptops or for their applications. it's based on that. There's some really fundamental parts of it that have been rewritten to perform well, but it's based on Postgres. So what does this mean? You can connect to it already. It uses the JDBC and ODBC driver, which means your application probably already can connect to it. There's no SDKs, and you don't need to write any code. There's no learning curve at all. It understands POSIX SQL. This is a industry standard compliant SQL language. SQL is a language you write to formulate your queries. And it understands the Postgres functions. So if you've used PostgreSQL before, you can pretty much jump straight in and start using it. One of the things I found really impressive about Redshift when I was playing around with it was you can actually analyze, here's a screenshot here, you can actually analyze your queries as they're being run or even retrospectively. So you can determine whether you need to upgrade your environment, how it's performing. Down the bottom here we've got our CPU utilization. You can even look at what sorting functions are being used in the background, if that's any relevance to you. Again, this slide's pretty much the same one as before, and this is what most Amazon products will look like. You can put it into your private network. You can secure it with security groups. You can have really granular control over which servers can access your data, which servers can connect to your database, that sort of thing. This is before you've even got to the point of logging on. And you can encrypt it, of course. Another really big point of differentiation with BigQuery is we do have a data center in Australia. If I ask what's wrong with this picture, it's probably because it's really pixelated. But aside from that, we do have a data center in Sydney. If you are a bank and you have legislative requirements to comply with, then you're probably okay. We also have an edge location in Melbourne, which means you can connect into the Amazon network locally, although the servers will be hosted in Sydney. Okay, so sizing and scaling. I've talked about how you need to architect and really plan the solution yourself. It's almost as if you own that infrastructure. You can very easily scale it up and down, but it's not automatic. If you hit the limit, if you hit the capacity of your cluster, whether that's by storage or CPU power, it's not going to fix itself until you go in and manually upgrade it. You can change the number of nodes and you can change the node type. So there are two categories of nodes. Some that are called dense storage nodes, which means it has a lot of storage capacity but not as much CPU. And the other category is dense compute power, which means it's got lots of CPU, not as much storage. So depending on your workload and your data set, you might go with one type or the other. And depending on the upgrade as well, you might have to experience a brief outage. I've done this a couple of times myself. The outage is about a minute, and it's not too bad. So what does it cost? Well, as I mentioned, it's an hourly cost per node. So even if you're not using it, if you spun up a cluster, you're paying for it. And it depends on the size of the node. That's probably a given. Now, I really wanted to give you an example here, but it's really hard to sort of convey, some relevance here. What will one node get you? So I've decided to do the demo first, and then I'm going to use that demo to kind of give you an indication of what the costs look like. Okay. So my demo. I'm going to be using the same data set as Graham here. So the global database of events, language, and tone. Same number of rows, same number of gigabytes, same events. Okay. I've chosen to do something that I feel is probably quite relevant to today. I hope there's no one going to be offended by this. No, it's not offensive at all. So I've decided to map out the relationship of Germany and Greece over time. So the database includes things like country interactions. It also, alongside those interactions, includes what's called a Goldstein scale value. This is the number between -10 and +10, and it kind of gives you an idea of how, whether it was a positive interaction or a negative interaction, and the intensity as well. So if it's -10, that's probably an act of war. If it's +10, I don't know, they had a nice dinner or something. If it's 0, it's probably like, someone got arrested or something. And so this is my video. So it's important to point out, this is not what Redshift looks like. This is just a client that's on my laptop. It's actually a Postgres client, which gives you an idea of how compatible it is with Postgres. Okay, so yeah. So along here we've got a list of my tables that we were playing around with, and this is the events table that we were querying before. Got a bit of a summary of some tables there, and we can see that it's nearly 320 million rows. So we head over to the SQL terminal. This is where we type in some queries, and to save some time, you can actually load it from disk if you want. You can save those queries, and it writes it to a little file. So here you can see we've got the country names. Actor 1 and actor 2 is basically which country initiated the interaction and which one was received. And it took us about just under a second to query that. 755 milliseconds. It's pretty quick. The query here is probably not quite as complex as Graham's one, but it gives you an idea. You can still crunch through a pretty significant amount of data in a really quick amount of time. Okay, so looking at numbers in a list is probably not that exciting. So I've decided to give you a bit of visual satisfaction here. I've used a third-party utility to chart out or plot out these points. The first thing that I notice, I'm not sure if you've noticed as well, is it's probably missing the data from the last couple of weeks. The other thing is, as well, I know that Greece joined the EU around 2000 or 2001, I think. It seems to be a lot more volatile before that. I'm not sure if that's a thing, but I'll let you do with this information what you will. Okay, going back to our cost example. So for this, to give you an idea of what you can get out of Redshift for your money, I've decided to take that cluster that we've just used to perform that demonstration and reduce it down to one of the smallest nodes you can get. It's a single node in the cluster, and it's a densely storage node, which means it doesn't have a lot of CPU. This is one of them. So this node costs 125 cents an hour, also known as $1.25, which is about $900 a month. And that query took 33 seconds to do. So the one we just did in that video, which took under a second, if you had one node that was one of the smaller ones, it'll take about 30 seconds. Still not too bad, I guess. Okay, so just to conclude this presentation on AWS, we used data pipeline for the ETL part of our equation. This is the part that picks up our data, performs any transformations, and then loads it into our analytics engine. Redshift is our analytics engine. It's a highly distributed and very scalable data warehouse database. Very scalable and very fast, as you've seen. But one of the really big points of differentiation here is you need to plan this yourself. You need to manage the infrastructure, you need to monitor it, and you need to architect it. You need to make sure it's performing. We do have a data center in Sydney, so that's a really good one. And if you wanted to try it out, you actually get a 1-month free trial. You can sign up with Amazon and use that for about a month. I think you get one small node to play with, but it gives you a good taste. Ooh. What's going on here?
Time's up.
Time's up. Well, I guess the rest of the slides are not going to be shown. How do we...
We're almost finished anyway.
Yeah. We can describe it to you vividly. Is that going to be good enough? All right. Well, if you were able to see this, we have a table of some differences between the products. We can see it on the screen here, so maybe we'll just describe them to you. Oh yeah. All right.
I'll stay up here with you.
I'd like to invite Graham to the stage now to help me with these, just in case the screen goes off again. All right, so the differences. So the first table here, we've got on the top row Google data flow, and the bottom one here is Amazon's data pipeline. These are our ETL solutions. So the biggest difference here, or one of the first difference, is the cost model. With Dataflow, you have a really granular cost model here. They charge you per minute. I think there's a 10-minute minimum, but that's still pretty good. Whereas in Amazon, you're paying per hour for the resources that you use. So remember, that's the EC2 resources or MapReduce. The setup here in Dataflow, you'll use code. So you have to basically use an SDK, write some code to define what you want to do. In Dataflow, data pipeline, the bottom one, you have a web console. If you want to, there's a bit more advanced options. You can write some JSON and define your pipeline. But you can just jump in with the web interface, and it's quite easy. In Dataflow, scalability is very dynamic. It's going to scale up your cluster as it needs to, and it's going to scale back down again when things quieten down. In pipeline, it's very manual. You define how many nodes you want and what type of nodes they are, and it will do exactly as you say. Security in Google land, it is high. Data is transmitted around within the Google network over very secure links, over private networks, and it does use encryption. But in Amazon land, you have the opportunity to create your private network. You have full granular control over the IP addressing, security groups, that sort of thing. And both of them are really quick. Again, this is going to really depend on your data set, what you want to do, all that kind of stuff. Okay, now Graham's just going to read out to you some differences for the analytics.
Okay, so Shane's just talked about, or he's just gone through the differences between data flow and pipeline, was it? I forgot. Okay, the ETL stuff. So this is the analytics, right? So we talked about it already. With BigQuery, you're going to pay per gig, per terabyte analyzed. That's your bulk cost. I know we talked about storage and streaming, but that's your bulk cost. Whereas it's per hour, all your VMs, all your EC2 instances running in your Redshift cluster. Moving on to setup, I would say BigQuery is pretty trivial. Like I pointed out, got a Google account, got a credit card, go nuts. A little bit more manual in Redshift, got to set up your cluster, define the amount of nodes you want, what types of nodes they are. Again, big differentiation. Google, you have no idea, sorry, not Google. BigQuery, you have no idea what's actually going on behind the scenes. Scalability, again, same as data flow. BigQuery will just scale up as you need it. A little bit more manual in Redshift. I feel like we're talking about the same things again. Security, high and higher. I think Shane's touched on this already, and he's gone through it. It just nudges AWS over the line. Just nudges it up a bit, having that VPC capability. Don't have that with Google. And yeah, they're both fast, right? You saw it. And the example that we gave you, at least for BigQuery, we went through a table with over 250 million rows, 320 million rows, 112 gigs of data in 3.2 seconds. But some of the examples we got working up with Telstra, we got data sets with 3, 4, 5 billion rows, terabytes of data, some semi-complex SQL aggregations counts. We grind through that data in about 20 seconds. It's just, it's phenomenal. Redshift, as you can see as well, that takes 733 milliseconds, something like that. They're both fast. So I would say back to you, Shane.
Sure. Okay, so I'm just going to wrap up a bit of a conclusion here, I guess. Some really important messages overall for both presentations here. We've just talked about some really cool technology, both from Google and Amazon. And the point that we're trying to convey to you is the big data can be manageable. We've just shown you can process this data. You can load it, transform it, or transform it, load it into your analytics engine, and analyze that in such a short period of time. One of the biggest differences here between cloud and having your own infrastructure is the barrier to entry. So both Google and Amazon, you've got free trials. You can jump in today and just start going, start trialing it out, and see what works for you. And I think the biggest one here is our end goal is not to crunch numbers or to have a really big cluster or whatever. It's insight. And this is not a new goal. This has been around since businesses have been around. Insight is the most valuable thing. But what is new is the data we're able to capture, the amount of data, and the tools we have available to us to analyze it. Okay, thank you very much.
So thanks to both Graham and Shane.